Hey everybody, Mr. Stewart here, and welcome back to Math We've Got This. In the previous screencast, we started off by introducing the exponent laws, and we looked at the one for multiplication. So what we're going to do in this video is we're going to pick up where we left off, and we're going to examine the quotient law. So for starters, let me kind of back up here a little bit. So what we're dealing with in this example, let's grab a highlighter here. So we have powers of the same base, so they both have p as their base, and we are dividing. Okay, hence the word quotient. So if you take a look over here to the right-hand side, let's grab my highlighter here because I did a little bit of pre-scripting. So notice that we have multiple factors of p in the numerator and the denominator. In fact, we have 8 in the top, 5 in the bottom. Now over here, you'll notice that I did an example that looked at what happens when we have like factors in the top and the bottom and what we can do to reduce them. So the goal is to find like factors and reduce them to 1 over 1. So that's what's happening over here. So if we take these first two factors between the numerator and the denominator, they can be divided by p, each of them, and that will reduce to 1 over 1. Okay, same thing happens. So find 2 more copies of p between the numerator and the denominator and keep on doing that. And you'll notice that 5 pairs, right, of that is p divided by itself are there, and they will cancel out. So again, cancel is just a fancy term for reducing like factors to 1 over 1. Okay, and what we're left with are 3 copies of p, and they're all being multiplied. So that means we have, let's grab the pen tool, that'll work a whole lot more better. And that's p to the 3rd power, or p to the 3. So what you noticed in your work, that is as you worked throughout the table, I'm willing to bet that you noticed that if I'm dividing these powers, I'm just subtracting those exponents. And again, this is super important. The bases are the same. Let's grab that highlighter. Bases are the same. And in this case, we're dividing. So that is the quotient rule or the division rule for powers that have the same base. All right, let's take a look at one more, and this is generally a common one. So these 3 examples you're seeing here in the videos are probably the 3 introductory rules or laws that students see for exponents. Let's take the last one, for example, and let's do some highlighting. So again, here we have a power, 10 to the 4. Okay, so it's in parentheses, and it has its own exponent. So it's like taking a power and raising it or making another power out of it. So by definition, what that means is we have 10 to the 4, and it's being multiplied by itself. Now, if we expand that out, and I'll use the dot notation for multiplication, certainly works a lot more. It's much more clean to write with that notation, and it's not as confusing with the x's. Whoop, I went a little bit ahead of myself. 4 copies of 10 there, multiplied by 4 more copies. There we go. Perfect. Okay, and then the product of those, right, if we multiply 8 10s together, 10 to the power of 8. Now you might have also noticed along the way, as you were studying these examples, that really you are multiplying those exponents together. So taking the 4th power, multiplying it by 2 to give you 8. So that is called the power to a power rule. So here, in general, so when you have x to the a and it's raised to some other power, in this case b, we take the exponents and we multiply them together. So x to the ab, that's also understood, that's equivalent to, it's like saying x to the a dot b, or if you like, it's equivalent to x to the a times b. And here we go, I'm getting my notification that my free trial is running out, and luckily we're at the end of the video.